Hello friends, welcome to engineering tutorial. So far we were discussing about the superposition theorem application in circuits involving dependent sources. So in the previous video related to network theory, we discussed about the basic concepts related to dependent sources, and we solved one question involving dependent sources and how we applied superposition theorem to determine whatever it was asked in that question. Okay, so this is another question involving dependent sources, and it has the given circuit elements. The important thing to consider here is this dependent source. This is a voltage source which is controlled by a current IO. So this is a current controlled voltage source. This is important. Current flowing through this 5 ohm resistor, and it has two independent sources, a 4 ampere current source and a 20 volt voltage source. And our question is to find out this I0 using superposition theorem. Okay, so the basic principle of superposition theorem we have to apply. So what we have to do is that first we have to consider one of the independent sources deactivating the other. Okay, so let us do that. First we will consider the 20 volt voltage source and open circuit the 4 ampere current source. Okay, so let us open circuit it. Okay, now we have to assign the loop currents, and then we have to put KVL equations. Okay, so let us say we have this loop current I1 and I2 flowing in this direction. So this is the loop current. So now we have to determine the branch currents. Okay, the branch currents. This is I1, this here is I2, okay, and this is also here I2. This we can either write I1 minus I2 or I2 minus I1 depending on whichever direction you want to take. So I am taking this I1 minus I2. Okay, and if you follow here, this current I0 is in opposite direction to I1, so we can write I0 is equal to minus I1. This is very important. Let us write it here at the top, because the space will be required to write the equation. So I0 is equal to minus I1. This is the first equation. So now if we apply KVL in this loop, this mesh, another thing, this is also I1. This is also I1. So if we apply KVL, okay, so now we will apply KVL. So if we apply KVL in this lower loop, it will become, using the second sign dominating method, I have already posted videos related to that. Okay, KVL, KCL, nodal analysis, mesh analysis, you can watch them. So in this lower loop, if we apply, it will get 20 minus 5 I1 minus 1 into I1 minus I2 minus 5 I0, we can write I0 as minus I1. Let us keep it in one sign, okay, minus I1. Let us write I0 as minus I1 minus 4I1 is equal to 0. Okay, so here it is I0 dash because it's the first case. Okay, so you will write it as I0 dash. So if we solve it, it will become 20 minus 5I1 minus I1 plus I2 plus 5I1 minus 4I1 is equal to 0. 5I1 minus 5I1 will get cancelled out. So it will become 20 minus 5I1 plus I2 is equal to 0, or we can write 5I1 minus I2 is equal to 20. This is the first equation. Okay, first equation, actually the second equation. This is the first important equation, this is the second. Okay, we have got until here by applying KVL in this lower mesh, the lower loop. Now we'll apply KVL in the upper mesh. Okay, so just write down in a separate place because there is lack of space here. So now we'll apply the KVL in the upper mesh. So now we will apply KVL in this upper loop. Okay, starting from this point using the second sign dominating method. So it will become 5I0 dash. So instead of I0 dash, we'll be using this relation. So it will become minus 5I1. Okay, then plus, okay, minus plus I1 minus I2 minus 3I2. So you please watch the video which I have posted related to how to apply KVL in the circuit, the basic concepts related to KVL, mesh analysis, nodal analysis. So you please watch those videos. Okay, I have posted it in my channel. You can click on the circuit theory playlist and there you will find it. So minus 3I2, then minus 2I2 is equal to 0. Okay, that implies minus 5I1 plus I1 minus I2 minus 3I2 minus 2I2 is equal to 0, or that implies minus 4I1 minus 6I2 is equal to 0. So this is the third important equation, minus 4I1 minus 6I2 equal to 0. Okay, so this is the first important equation, this is the second, this is the third. Now we have to solve them. Okay, so we have got these three equations, equation number 1, 2 and 3. Our objective is to find out I0 dash, which is minus I1. So from these two equations, if we find I1, we can find out I0 dash. So we have to figure out a way how to cancel I2. Okay, so if we multiply 6 here, this will become 30. Okay, I'm multiplying 6 here in this equation, it will become 30. 5I1 minus this becomes minus 6I2 and this becomes 120. I just multiplied 6 in this equation. 30I1 minus 6I2 is equal to 120. Now if we subtract these two equations, then it will become plus, become minus. This 2 will be cancelled out. This will become 34I1 is equal to 120. That implies I1 is equal to 120 by 34, or it is equal to 60 by 17 ampere divided by 2, both the numerator and the denominator. This is I1. I0 dash is minus I1. So I0 dash is equal to minus 60 by 17 ampere. This is the end objective, okay, to find out I0 dash flowing through this 5 ohm resistor considering the 20 volt voltage source, neglecting the 4 ampere current source. Now we have to reconnect the 4 ampere current source and short circuit the 20 volt voltage source, and again find out this current for that case, okay, and then we will add them together. Okay, so let us do that. Okay, so now we will perform step 2, in which we will reconnect the 4 ampere current source and short circuit this voltage source, okay, considering the 4 ampere current source only. So we will short circuit this voltage source. Now we have to determine this current double dash because this is the second step. This is also double dash. Okay, so now let us assign loop currents and find out the branch currents. Okay, let us say this is I3, the loop current. Here it is I4, and here it is I5. So now we have to find out the respective branch currents. So here it is I3, here it will be I3 minus I4 downwards. This is I4, sorry, downwards, or I4 minus I3 upwards. In whichever way you want, you can do that. This will be I3 minus I5 downwards, or I5 minus I3 upwards, whichever side you want to take as dominating side. Okay, and this current will be I5 minus I4 towards the right, I5 minus I4. Okay, and this will be I5, and this will be I4. This will be I4, yes. Okay, now we will apply the KVL equation. Another important thing to notice here is that I3 and 4, they have the same direction, so I3 is equal to 4 ampere. This is the important relationship here. I0 dash is equal to I3 minus I5. This is the second equation important. Okay, I0 double dash is I3 minus I5. Okay, that is the important thing. So let us apply the KVL equations, first in this mesh and then in this mesh. Okay, let us assign the polarities as well, plus minus, plus minus, plus minus, here also from positive to negative, plus minus, and here also plus minus. Okay, let us apply KVL. So it will be 5 from here, 5 into I3 minus I5 minus 1 into I5 minus I4 minus 5 I0 double dash. We can write it that way, but we want to keep it in terms of I3, I4 and I5, so we will substitute this value minus 5 I0 double dash, which is I3 minus I5 minus 4 I5, which is equal to 0, this lower mesh. So it will be, that implies here 5 I3 minus I5 and minus 5 into I3 minus I5, that will get cancelled. Okay, so this is I4. Okay, so it will be minus I5 plus I4 minus 4 I5 is equal to 0. Okay, that will be plus minus 5 I5 minus 5 I5 plus I4 is equal to 0. This is the third equation. Okay, this is the third equation, minus 5 I5 plus I4 is equal to 0. Now we will apply KVL in this upper mesh to find out the fourth KVL equation. Then we will determine the values of I3 and I5, which is required to determine I0 double dash. Okay. So now we will apply the KVL equation in this upper mesh, this upper loop. So we will get the fourth KVL equation involving I4 and I5. Then we will determine this I0 dash, I0 double dash, I3 minus I5. Okay. So our objective here is to find out I5. So let us apply the KVL equation here. Starting from this point, it will be 3 into I3 minus I4 minus 2 I4 plus 5 I0 double dash, which is equal to I3 I5 plus 1 into I5 minus I4 is equal to 0. That implies 3 I3 minus 3 I4 minus 2 I4 plus 5 I3 minus 5 I5 plus I5 minus I4 is equal to 0. Or we can write 8 I3 minus 6 I4 minus 4 I5 equal to 0. Now I3 is equal to 4, so 8 I3 will be equal to 32, or we can write 6 I4 plus 4 I5 is equal to 32. Okay, so we got another equation in terms of I4 and I5, which is the fourth equation. Okay, so 6 I4 plus 4 I5 is equal to 32. It's the fourth equation. So we got the four equations. Our objective is to find out I0 double dash. I3 is known, 4. Now we have to find out I5 from these two equations. So let us do that. So we have got these two equations involving I4 and I5, from which we have to find out I5 so that we can put this value to get I0 double dash is I3 minus I5, where I3 is known, 4 ampere. So we need to find out I5. So we have to figure out a way to eliminate I4 so that we can get the value of I5. So here if we multiply 6 in this equation, it will become 6I4 30I5 is equal to 0. 6 into 0 is 0. Now we'll subtract it, minus will become plus, come minus. So it will become, these two will get cancelled out, to become 34 I5 is equal to 32, or I5 is equal to 32 by 34, okay, or which is equal to 16 by 17 ampere, okay. But we have to find out I0 double dash. I0 double dash is equal to 4 minus I5, which is 16 by 17, which is equal to 68 minus 16 by 17, which is equal to 52 by 17 ampere. Okay, 52 by 17 ampere. So we got our value of I0 double dash. I0 double dash. I0 double dash is equal to 52 by 17 ampere. We had calculated I0 dash, okay, the other case, the I0 dash we calculated. Now we have to just add these two values to get the final current, okay. Okay, so now we will determine the value of this current, unknown current, which was our main objective. So in the first case, in which we considered the 20 volt voltage source and deactivated the 4 ampere current source, we determined the value of this current in that case as minus 60 by 17 ampere, and the direction was downwards. I0 dash, it was downwards. It's very important, this direction. And in the second case, in which we considered the 4 ampere current source and deactivated the 20 volt voltage source by short circuiting it, we determined this unknown current I0 double dash in that case as 52 by 17 ampere, also downwards. Now this current I0 which has been asked, its direction is also downwards. So these two are in the same direction. So I0 will simply be I0 dash plus I0 double dash, because they are in the same direction. If they would have been in the opposite direction, we would have used the minus sign. So it would be simply be minus 60 by 17 plus 52 by 17, which is equal to minus 60 plus 52 by 17, which is equal to minus 8 by 17 ampere. Okay, minus 8 by 17 ampere. This is the value. So this question is a bit lengthy and there are a lot of KVL equations involved, because there are 3 loops, 3 meshes involved in this circuit, and also there are 2 independent sources, one current source, one voltage source. So there are a lot of equations involved in it. So you have to have some patience. You solve each of these equations carefully and then find out the requirement, okay, the end objective, which was to determine this current for each of the cases, and then finally we have to add them together as per the principle of superposition theorem. The final response is the sum of the individual response by taking or considering each of the independent sources separately, one at a time. So this is our final answer, minus 8 by 17 ampere I0. Okay, so I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to engineering, science and technology. Have a great day. Thank you very much.